Hello students. So in this video we are going to discuss about the pure rolling and the different types of pure rolling. Okay, so let's discuss about pure rolling. So basically pure rolling are of two types. One is uniform pure rolling, uniform pure rolling. Another is accelerated pure rolling. Okay, so let's discuss about uniform pure rolling. And we'll also discuss some types of questions that are coming on this. Of course, in JEE this year they have removed it, but this topic is important, and they can ask some questions not directly related with this topic, but application oriented questions, right? So as we discussed already, that if this body is pure rolling, this is the center of mass. So center of mass will have a velocity, right? V center of mass, and suppose R is the radius of this round object. So also assuming that this platform is at rest, okay, or the ground is at rest, okay. It may not be at rest, that case also we can consider, but for this case we have seen that this point of contact P, velocity of point P is 0 because it is at rest. So in this case we have derived that velocity of center of mass is going to be omega r, right? This is the condition for pure rolling and uniform pure rolling. Now uniform pure rolling means this point P is just moving in such a manner that there is no sliding action happening here. No sliding action happens, no friction is going to act. Even if this surface is a rough surface, the friction here will be absent, okay. Friction here will be 0. Zero friction will act here in uniform pure rolling, even though the surface may be rough, okay. This is what you have to understand here, okay. Now another case, as I told, that what will happen if there is a platform here, and that platform is like a plank, you can say. This is a plank. And let us say the plank is moving in this direction with the velocity of Vp. Vp is the velocity of the plank, or V plank you can write. Okay, so what about the point of contact? If you want that there is no sliding happening, right, or pure rolling happening, then velocity of this point P, point of contact, must be same as velocity of plank. Okay, velocity of plank. That is what it is. And here you can again in the same way you can derive that this is the center of mass, and center of mass is going with this velocity, and velocity of P with respect to center of mass. So if you draw the velocity of point P with respect to center of mass, so it must be going in this direction, velocity of P with respect to center of mass. So velocity of point P with respect to center of mass is minus omega r. Here of course we are taking point which is at the periphery, right? This is velocity of P minus velocity of center of mass is minus omega r, okay. And now velocity of point P must be same as velocity of Planck. So from here you can see velocity of center of mass will be velocity of point P plus omega r, right, or omega r plus velocity of P. So you can conclude that velocity of center of mass will be omega r plus velocity of Planck. P means this is the velocity. P means same as velocity of the Planck, okay, right. So this is the condition. Of course, if the Planck is at rest, that means it is on the ground. You can say that V of Planck is 0, then this you will get this condition. But in such case, you can have this also, right? So here you should know about what is called forward slipping, backward slipping, right? So let us say in the first case that we have discussed, velocity of center of mass is greater than omega r, or another case can be velocity of center of mass is smaller than omega r. If it is equal, then it is pure rolling. But if velocity of center of mass is greater than omega r, this is called forward slipping. Forward slipping. This means it is rolling with slipping. It is not pure rolling. Okay. Pure rolling means V center of mass is equal to omega r. But if it is greater than omega r, that is called forward slipping. V center of mass is less than omega r, that is called backward slipping. Backward slipping. Okay. Backward slipping. Right. Similarly, here also you can make condition for forward and backward. So in this case, if you consider pure rolling, this is condition for pure rolling. Center of mass velocity will be omega plus v flat. But if velocity of center of mass is, let us say, greater than omega r plus velocity of flat, then it is forward slipping. This is the condition for forward slipping. Similarly, in the second case, if you consider velocity of center of mass smaller than omega r plus velocity of flat, then it is backward slipping. Okay. But anyway, generally questions are not coming in rolling with slipping, forward or backward. But questions will come on pure rolling, so we can consider that, right? This is about uniform pure rolling. Now we will see about accelerated pure rolling. But before going to that accelerated pure rolling, you can just see one condition. For example, suppose this is a rough surface. Let us say this is a rough surface, and coefficient of friction is mu. And let's say a body, a round object which is under rotation with angular velocity omega. It is just kept here. Okay, it is just kept here, or it is released. Released here means the velocity of center of mass is 0 here. Okay, released means center of mass velocity 0. It is just kept here, but it was under pure rotation. The body was under pure rotation, and it was just kept on this rough surface. Then after some time the body will have pure rolling, right? So pure rolling will happen after some time. Pure rolling will happen after some time. They may ask you to find out what is the time after which pure rolling will happen. Let's say at time 0 you have kept it, and after some time t equal to t, pure rolling will happen. So as I told, pure rolling means now let's say initial angular velocity is omega naught. Now when pure rolling will happen, it will be having angular velocity omega, and this will be the velocity of center of mass. So for the pure rolling condition, v center of mass is omega into r. That is what is pure rolling will happen. So you need to consider friction going to act, but after this point there is no friction. Here onwards no friction will happen. But before or in between these two interval or two instant of time, there will be friction. Friction will act. And how friction will act, that is what we have to understand. Now let us look at the point of contact. So as soon as you have kept it, you can clearly see that the velocity of this whole object has increased, because the center of mass has increased. It was initially 0. So there must be friction in this direction, right? This is what is friction acting, and you can say that this friction is mu times normal. And if you take mass of this object is m, so normal is equal to mg. That you know. You don't have to draw free body diagram. Okay, so that means friction. And if you see, friction is the only force acting on the body, so friction is equal to mass into acceleration, right? So from here you know that acceleration that is going to happen is mu into g. So with this acceleration, the center of mass is getting accelerated, and we can say that v equal to u plus at. We can apply this formula. So final velocity v equal to u plus at we can apply, isn't it? So final velocity, which is omega into r, you can write. Initial velocity 0, acceleration is mu into g into t, right? So you can calculate from here omega r is equal to mu g t. Time can be calculated, but let us say we don't know what is omega final, right? That final omega you need to calculate, then only you can solve this, isn't it? To solve this equation you need to know omega. Radius is, let us say you know that radius, and moment of inertia I about the center of mass, they may give you I center of mass. I center of mass means I center of mass. Let's say for example it's a disk, then they will give you I center of mass is mr square by 2. If it's a ring, it is I center of mass is just mr square. So I center of mass for different bodies will be different. But how do you calculate omega? For that you have to study the rotational motion of this body, and if you see, you need to see now the torque. So about the center of mass, if you see, the torque that is acting is because of friction, because this is friction, right? Friction is going to create a torque like this, right? There is a torque created due to friction. What about other? Normal will pass through center of mass, mg will also pass, so they will not create any torque. Torque is created due to that. So torque or net torque you can say is due to friction into that distance is r, f into r. But remember, the angular velocity initially is in this direction and friction is acting, and the torque is acting in opposite direction. So this torque is going to be a retarding torque. This torque is a retarding torque. Retarding means it will try to oppose the motion, angular motion or rotational motion. So you should put a minus sign here, right? Then you can calculate this friction. Of course you can write mu times normal, which is mu mg into r, and net torque you can write as torque is I into alpha, so I center of mass into alpha, and alpha from here you can calculate, so minus mu mg r by I center of mass, right? You can write this. So using this alpha you can calculate what you can calculate. You can use omega, angular motion you are going to study, so omega equal to omega naught minus alpha t. That means plus alpha t only, but it is minus, so you can substitute. So final omega you can calculate from here. Omega naught initially it will be given minus mu mg r by I center of mass into time t, right? So now you know you have this equation and you also have this omega. So this omega you can substitute here in the first equation. Let's say you tell this as first equation, this is second equation. So from the second equation omega can be calculated and substituted in the first equation. Let us do that. So omega naught into r minus mu mg r square by I center of mass into t is equal to mu g t. Now you can solve the time, bring the time factor one side, so mu g factor will come, mu g t factor can come, right? Mu g t, so 1 plus mu g t, so mr square by I center of mass is equal to omega naught r. So you are deriving an important formula here. Of course many people want to just remember this formula, but you need to understand what is happening here. So mu into g, 1 plus mr square by I center of mass. You can remember this formula, definitely you can remember. So any round object and the same conditions in the questions given, then you will be able to find the time after which pure rolling happens. This is the time after which, time after after which pure rolling starts. Okay, so that's the important form. Then let us go to the next. So this is what is a pure rolling, right? Uniform pure rolling. Then let's go to the next. Now we'll understand accelerated pure rolling. Accelerated pure rolling. Accelerated pure rolling. So accelerated pure rolling means the object is a round object, again any round object it can be, and here also you can consider the same approach. Okay, approach will be same, but only thing is that there can be friction acting. Okay, so let us consider that this is the flat surface, the center of mass, velocity of center of mass, and here you need to consider some case to understand this properly. Let me consider that there is a force applied at the top. I am just taking a case here to make things clear, because things may change according to the given question. So I am just taking a force. This is an applied force, and the body is undergoing accelerated pure rolling. Okay, so the condition for accelerated pure rolling means, again you can understand this is the point of contact P, let us say. So acceleration of this point P must be same as that of the acceleration of the ground or the contact surface. Here this is the ground, and if I consider acceleration of the ground at rest, if it is at rest, then it has to be taken as 0. So acceleration of point P you have to take as 0. Again the same concept. Okay, so this point P, right, so with respect to the center of mass, this point P is under acceleration, so it is at a distance of r, right? So the acceleration, what are the acceleration of this point P? If you consider here, right, acceleration of this point P, it is with respect to ground. So with respect to ground, it will be having a or with respect to center of mass, right? So this will be the acceleration of the point P with respect to center of mass, right? This is of course the direction of velocity. This is the direction of velocity. So acceleration of this point P with respect to center of mass, this direction is the velocity direction, P with respect to center. But acceleration will be centripetal acceleration, which will be omega square r. Omega square r, of course that is centripetal acceleration. But what is the tangential acceleration in the direction of velocity? Okay, so let us consider the tangential direction in the direction of the tangent. So in the same direction we can have this acceleration of P with respect to center of mass, that is the tangential acceleration. Tangential acceleration is r into alpha, and it is going towards the left side, so you can keep a minus sign here, isn't it? So a minus sign can indicate the direction of acceleration, tangential acceleration, minus r into alpha, isn't it? So that is minus r into alpha. Centripetal acceleration, here we are not considering, which is of course towards the center, right? So while you are considering the rotation of the point P with respect to center of mass, we are only considering here the tangential acceleration. Of course, the resultant acceleration of the point P will be both sum of centripetal and tangential, but let us consider this as the tangential acceleration. Same manner, this you can write as acceleration of P minus acceleration of center of mass is equal to minus r alpha. Again acceleration of P has to be 0, so minus acceleration of center of mass is minus r alpha, so therefore acceleration of center of mass is r alpha. Okay, why we are considering it only the tangential acceleration? Because it is parallel to the surface, and friction can act only parallel to the surface, isn't it? Parallel to the surface, but of course we have centripetal acceleration as well, which is acting towards the center. Okay, but here we are considering only parallel to surface because we are considering whether friction can act or not. Okay, so that's the condition for pure rolling. Acceleration of center of mass is equal to r alpha. Okay, r alpha. So definitely here friction is going to act, and how does the friction act? That's what we have to understand in this accelerated pure rolling. So here, how does friction act? Let us say you don't know. Let us say the surface is very smooth and this force has acted upon it. Okay, let's consider this diagram again to understand it properly. So consider this object, round object, and let us say this is the center of mass and this is the ground. Okay, and let's say you have applied a force. Suppose if you apply a force at the center of mass, then what will happen? Can you guess? If you apply force at the center of mass, or the line of action of the force passes through the center of mass, then the body will just slide. There is no possibility of rotation because the force is going to act at the center of mass, isn't it? Right? It will try to, but if you apply force at somewhere else, let us say you consider the force acting somewhere else. Let us say that I am just taking a case where you are applying force here. Okay, here you are applying force. Now because of this, suppose the surface is a smooth surface, then body will try to pure rolling, pure rotation should happen, pure rotation. But because there is a friction, this point of contact has a velocity with respect to surface in this direction, so friction must act in this direction. So here you can consider, of course, friction you can take any other direction if you are not sure. So answer will be with proper sign, plus minus will come. Okay, but let us say friction is acting forward, then what is the condition for pure rolling? So pure rolling condition, I told the acceleration center of mass is r into alpha. This condition for accelerated pure rolling we have to apply. Okay, so if you consider, first of all, consider the acceleration of the system or center of mass. Net force. What are the forces acting? Vertical forces mg and normal will definitely balance. This mg and normal, which is acting like here. So normal and mg are balanced. Horizontal forces, the net force. Horizontal forces, acceleration net force f plus f divided by mass. This is the acceleration of center of mass. What about angular acceleration? Angular acceleration is net torque by I center of mass, right? How do you calculate net torque? So to calculate net torque, we have to consider torque due to this and this. So both the torques, torque due to the applied force F, which in this direction, right? This direction, and torque due to this friction is in opposite direction. Both the torques are opposite directions, so you consider the resultant torque or net torque. So net torque that you are going to consider is F into R minus small f into R, right? Divided by I center of mass. So here you can see it will become F minus small f in times R by I center of mass alpha. Now apply the conditions. As I told you, calculated acceleration, you calculated alpha. Now apply the condition for pure rolling. For pure rolling, A center of mass is R alpha. Apply that condition. So A center of mass is F plus F by M. A center of mass is R alpha. So F minus F into R square by I center of mass. Right? So from here, some important results can be derived. For example, if you write this condition as F plus F by F minus F, and you can write this as mr squared by I center of mass. Now from this applying comparator dividend, you can apply. One time you can add them, one time you can subtract them, isn't it? So one time when you add them, 2 capital F will come, or F you can take, because you have to divide again by 2. So F plus F, F minus F, when you subtract it, it will become this. So this will become mr square plus I center of mass. This is mr square minus I center of mass, right? And from here you can calculate, if you want friction you can calculate, right? F friction you can take. Friction will become F times mr square minus I center of mass by mr square plus I center of mass. And you can apply condition on friction, that the condition for friction is it is less than equal to the maximum friction, right? So maximum friction is mu, and so this condition of friction less than equal to mu times normal can be applied. Normal is of course equal to mg. So you can apply this condition and you can see what kind of things that is possible. And of course here I center of mass will depend on different objects, and you can consider the calculations of that, right? So I hope you have understood this concept. So accelerated pure rolling is this one. Another accelerated pure rolling is on inclined plane, that we'll see afterwards. Okay, so thank you for your attention.